All right, so let's take a look at the homework for 6-2, and we'll work on doing our key together. Here we have a rational function. I'm going to go ahead and graph it by going to my y is equal to screen, 3 divided by parentheses 2x minus 4. And I can go ahead, and I'm not surprised by that graph. I don't have any squareds, so I don't have everything in one half or the other half. This minus 4 is going to mean that my graph has moved in the positive direction 4. Because I have more x's down bottom than up top, I know my horizontal asymptote is y is equal to 0. And I know my vertical asymptote is going to be where my denominator is equal to 0. So my vertical asymptote is going to be the equation x is equal to 2. So I come over here and I draw my dotted line. And I'll come here and I'll draw my horizontal asymptote at y is equal to 0. When I go to my table of values, that can help me get some points to graph. So I'm going to go ahead and look around my asymptote. And I'm going to have over 1 down 1.5, over 0 down 3/4, over -1 down 1/2, and it gets smaller and smaller and tighter into that axis. So I know there's my asymptote, and I know here's my graph on this side of my vertical asymptote. When I look over at 3, I go up 1.5. 4 is over up 3/4. 5 is about at 1/2. So this graph's asymptote is going to look like this. My domain is going to be from negative infinity up to my asymptote. I'm going to hop over my asymptote and continue on for my x values. My y values are going to start at negative infinity. They're going to come up to and hop over my asymptote and continue on. My zeros are going to be none because my horizontal asymptote and my graph doesn't ever cross it. And my y-intercept is going to be where I have an input of 0. I can go back to my calculator. An input of 0 gives an output of negative 0.75. As x approaches infinity, from both the negative and positive side, y approaches 0, because that's where my two graphs are headed. Is it a function? Yes. Is it one-to-one? Yes. Is it continuous? No. I have to pick up my pencil to finish drawing it. When we look at my extrema, I have none because I have no hills and valleys. My graph is never going to be constant. And my increasing interval, as my values go from here and here, there is no increasing interval. And then if you look at my decreasing interval, that happens all the time with the graph. So because it happens all the time with the graph, we're going to start at negative infinity, come up to our asymptote, and then notice at this asymptote, we're going to hop over and talk about this side of the decreasing. So sometimes we group them all together, but it's best practices to split them and talk about the two different behaviors of the two different parts of the graph. All right, let's take a look at number 2. When we look at number 2, we have 1 power of x in the numerator, 1 power of x in the denominator, which means when I find my horizontal asymptote, I'm going to look at that fraction a over b, and I'm going to say that y is equal to 1/2 is going to be that boundary marker for this graph. So there's my y is equal to 1/2. My vertical asymptote is going to be when 2x plus 1 is equal to 0. So 2x is equal to negative 1, x is equal to negative 1/2. So that vertical asymptote. Then I have an idea of where my graph is going to fit. So here, x is equal to negative 1/2 is my vertical asymptote. My domain is my graph is going to come from negative infinity up to that asymptote, hop over it, and continue on. My range is going to start at negative infinity. It's going to come up to that horizontal asymptote and then continue on. I'll go ahead and I'll enter my equation into my graphing calculator to take a look at the graph. Make sure I use parentheses, x minus 2 divided by 2x plus 1. I'll go ahead and take a look at the graph. See, that kind of fits where I had predicted that things were going to be going. So I'm in good shape. When I go to graph it, we'll go ahead and put some values on the coordinate plane for us. So I know I go over negative 1, up 1, 2, 3. I know I go over 0, down 2. I go over 2, up 0. Now those are some interesting dots to have, but because I know the behavior of the graph and what's happening, I can continue. Negative 2 is going to be up 1 1/3. And then negative 3 is going to be at 1. So I can see the behavior of this graph. Looks like that. And I can see over here, an input of 1 is negative 1/3. I can see this graph's behavior here. When we're talking about our zeros, we're looking at where does my graph have an output of 0. And I can look at this table of values and say that when 2 goes in, 0 comes out. When 0 goes in, negative 2 comes out. My end behavior, whether as x approaches negative infinity and positive infinity, they're both approaching that asymptote of positive 1/2. Yes, it is a function. Yes, it's 1 to 1, but no, it's not continuous. When I'm talking about my extrema, there's no hills and valleys, so there are none. There's nothing, never a time when it's constant. And then when I look at my increasing versus decreasing, it's always increasing, but best practice is to write it for each function separately. So from negative infinity up to this negative 1/2, it is increasing. And then from negative 1/2 up to positive infinity. And there's never a time that it is decreasing. As I move left to right, my graph is always getting bigger. All right, let's look at our next homework. Problem number 3. I have the same number of x's on the top and bottom. So I know that my fraction, a over b, is going to be my horizontal asymptote. So y is going to be equal to negative 3 over 1. So this horizontal line is going to be my boundary. When I look at my vertical asymptote, in order to find my vertical asymptote, when does my denominator equal 0? Because that's going to determine where I get an error. So 1, 2, 3, 4, right here is where my graph is going to have its boundary markers. When I'm looking at my domain, I'm going to go from negative infinity up to my asymptote, hop over it, and continue on. When I'm considering my range, I'm going to start at negative infinity. I'm going to hop over my asymptote and continue on. Now sometimes my range and my output can be different, so I'm going to make sure that I verify that by graphing it in the graphing calculator first. So my function, negative 3x divided by parentheses x minus 4. I'll go ahead and I'll take a look at the picture of it, and I'm going to try to make sure that, yep, I have that horizontal asymptote. That looks right to me. So we'll go ahead and say from negative infinity all the way up to that negative 3, hop over it, negative 3 up to positive infinity. When I'm looking at my zeros, it looks like I have 0, 0 as my x and y intercept. So we'll go ahead and make sure that we graph that and recognize that 0, 0 is going to be our x and our y intercept. As x approaches negative infinity, let's go ahead and finish graphing. So we'll go ahead and look. We have 0, 0, and it looks like 1, 1 is a point, over 2 up 3 is a point, and over 3 up 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be a point. Negative 1 is about negative a half-ish. Negative 2 is negative 1, and this one is just past. So I can see the curve of this part of the graph. It's going to continue up. Let's go to the other side of our asymptote at 4. Oh my goodness. Over 5 down 15. That's going to be way down. Over 6 down 9. That's also pretty far down. Over negative or positive 7. So 4, 5, 6, 7 is down 1, 2, 3, 4, 5, 6. That's our first one that's on the point. So we recognize 8 and negative 6. This one's going to go at a wider curve. Hey, that happens as a result of that 3. That's that look of that stretch for us. All right, let's finish filling in our information about our graph. As x approaches negative infinity, y here is approaching that horizontal asymptote of negative 3. Uh-oh. 1, 2. Did I not graph it correctly? Negative 3. So it's not this one. Make sure we graph it there. Y is approaching negative 3. We need to make sure that that matches. Negative 1, negative 2, negative 3. Is it a function? Yes. 1 to 1, yes. Continuous? No. We have no extrema. Never a time that it's constant. My increasing intervals, if I look here, it's always getting bigger. But we're going to have this vertical asymptote split the two parts of my graph. So we'll say it's increasing from negative infinity up to that vertical asymptote at 4, and then it picks up again at 4 to positive infinity, and our decreasing interval is none. Okay, on the back, let's talk about what asymptotes go with each of these graphs. Because I have the same number of x's, my horizontal asymptote is going to be the equation that's created from their coefficient. So y is equal to negative 3/2 as our horizontal asymptote. And our vertical asymptote is going to be when my denominator is equal to 0. So when does negative 2x plus 2 equal 0? 2 is equal to positive 2x. So x is equal to positive 1 is going to be that asymptote. Given the graph, what could be the equation? All right. So because I see a horizontal asymptote at y is equal to 0, I know I have more x's in my denominator. So not this one, because that's going to give me right there. My whole graph is shifted to this way, which means an x plus 2 makes sense. when I look at my vertical asymptote, I can see that a value of x cannot equal negative 2 because that's where that asymptote is going to be. All right, so number 6, given the graph of the function, what are the asymptotes? So I look here and I see my horizontal asymptote at y is equal to negative 3. And I see a vertical asymptote at x is equal to negative 1. Given the function x minus 3 over x squared, I've got more x's in the denominator. As x approaches infinity, and I can go ahead and graph that. So I can see as x approaches infinity, remember they're going to approach their horizontal asymptote. So that's going to be y is equal to 0 because I have more x's in my denominator than my numerator. So when I look here, x plus 1 over x, we'll go ahead and take a look at this graph. So just so we can see it again, when I graph my x minus 6 over x squared, I have my horizontal asymptote at y is equal to 0. There it is. So then as my x approaches positive infinity, that's going to be where my output goes. All right, let's take a look at this last one for number 8. We'll go ahead and graph x plus 1 divided by x. I've got the same number of x's, my top and bottom, so I know my horizontal asymptote is going to be at y is equal to 1. So when I look here, the interesting thing is this graph is never going to hit the y-axis because my vertical asymptote tells me that x cannot equal 0. So because it can never equal 0, it's never going to hit my y-axis, and I can see it hits my x-axis once here. All right, keep working on this homework.